When disasters occur, victims can be trapped under rubble or debris, or in buildings that are dangerous to enter. The victim usually has no supply of food, water, or other necessities, making the race to find them even more urgent. Search and rescue teams must often go into areas that are dangerous or not easily accessible.
Hello, my name is David. A few months ago, my science class was learning about the muscular system of the earthworm, and I wondered, is it possible to build a robotic earthworm? If so, it may be useful in search and rescue applications by crawling across rough surfaces and tunneling through rubble.
I did some research and found out that earthworms move by a method called peristalsis, a process consisting of the contraction and relaxation of muscles that travels in a wave-like motion down the worm. I thought about what kind of actuators to use and settled on pneumatics since they're inexpensive, lightweight, and provide a large range of motion. I experimented with a mylar balloon and noticed that when the balloon inflated, the diameter decreased and the thickness increased. The opposite happened during deflation. Similar to the muscles of the earthworm, I found that the balloon had trouble deflating by itself, so I experimented and found that surrounding the balloon with springy pieces of styrene forced it to deflate. I began by designing the robot on 3D CAD and on paper, and then began to create a first prototype. And here it is.
There is an Arduino microcontroller sending signals to relays, which send signals to valves to open and close.
The valves are connected to a pneumatic circuit which channels air into the balloons. When the balloons inflate, the robot stretches out, and when the balloons deflate, it contracts. When one side of the robot inflates more than the other, it changes direction. I wrote code to program the Arduino and then tested the robot and revised the code as needed. I plan to continue developing my robot to improve its performance. In the future, I plan to add a third row of balloons to allow the robot to move in 3 dimensions. I also plan to add GPS, heat sensors, and MEMS vibration sensors so that the robot is capable of sensing disaster victims.